KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss example problems, right? In our previous class, we focused to discuss what is center of mass and how to find the center of mass of two particle system which were lie on x-axis or distributed along x-axis. At the same time, what is the center of mass of a system having n particles, all are distributed along the x-axis. After that, when two or three particles lie in a plane or in a space, how to find the position of center of mass means how to find the coordinates of center of mass, so that how to find the position of center of mass also we discussed. After that, in case of continuous bodies, because of not possible to find center of mass or mass for individual particles, because of difficulty in calculating, we replace the summation symbol with integration symbol. So that is what like calculus method. So by using that also we found and we discussed how to find the center of mass in case of continuous bodies, okay, like scale, right? So continuous bodies means like meter scale, otherwise meter stick or flywheel, etc. Okay. So this is the information we had in our previous class. In this class, for some of the objects or for some of the particles, we are going to find center of mass mathematically by using the concept what we discussed in our previous class, right? So it is what example 7.1. I already told you center of mass is an imaginary point where the total mass of an object is supposed to concentrate. So I will repeat once again because of the importance of the definition. Center of mass is an imaginary point where the total mass of an object supposed to concentrate. Right. See here, first example 7.1. Find the center of mass of three particles at the vertices of an equilateral triangle. Full stop. The masses of the particles are 100 grams, 150 grams and 200 grams, right, respectively. Each side of the equilateral triangle is 0.5 meters long. Okay. So in this problem, there are three particles, right, like that is what A, B, okay, and O. This is what O, right? O, A, B are the three particles according to the question and this picture. So for these three particles, mass also given, that is what 100 grams, 150 grams, 200 grams respectively. And you know, these three particles exist at the vertices of an equilateral triangle. Vertices of an equilateral triangle. So that the side of the each side of the equilateral triangle is 0.5 meters long. 0.5 meters long. So the distance, this is what you know, what is the side of the triangle, what is the angle of the triangles, right? You know, what about the three angles? You know, what is equilateral triangle? So equilateral triangle means all sides are equal now. So that when it is 0.5 meters, it is also 0.5. It is also 0.5. See this picture also, ma. Okay, right. You know very well. If you take this point, the coordinates of this particle or points is 0, 0. 0, 0. That's we know. Similarly, when we go here, it will be different because it is 0.5. No, it is 0.5. When it is 0.5, it is what? X coordinate is 0.5, but y coordinate is 0. Y coordinate is 0. Similarly, because of this equilateral triangle, if you draw a line that is like normal from this vertex to this x-axis, this will meet here, that is what? 0.25, 0. 0.25, 0, right? When you go to find out the coordinates of point B, that is what? Particle B, it will be like this. That is what? 0.25, 0.25 root 3. 0.25, 0.25 root 3. So the x coordinate is 0.25 and y coordinate is 0.25 root 3. 0.25 root 3. We can calculate it, that is what? Geometrical picture, and because of equilateral triangle and because of 90 degrees here, and you know what is Pythagorean theorem. By using all the things, we can find the y coordinate of B particle, the particle which is at present B, the particle B which is present at one of the vertices of equilateral triangle, right? With the x and y axis chosen as shown in the figure, the coordinates of points O, A, B forming the equilateral triangle are respectively 0, 0, 0.5, 0, 0.25, 0.25 root 3, as I told you while showing this figure, right? Okay. And let the masses, already they have given, right? Let the masses 100 grams, 150 grams and 200 grams be located at O, A and B respectively. Then, so what about x coordinate of center of mass? It is what? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So this formula already we know in our previous class, right? So we discussed when three particles are present, how to find the x coordinate of center of mass and y coordinate of center of mass. So basically, when you find the x and y coordinates and sometimes z coordinates also for center of mass, it will give you position. So based on the position, you can find velocity of center of mass. Afterwards, you can find the acceleration of center of mass and the moment of center of mass, that we will discuss in our coming classes. But anyhow, here to find the position of center of mass, we have to find the coordinates of center of mass, right? So it is what? X coordinate. After this, just you have to substitute the things what we have already here. m1 100, x1 0 plus m2, it is what? 150. What is the x2? It is what? 0.5. m3, what is the x3? 0.25 divided by 100 plus 150 plus 200, that is equal to 5 by 18 meters, right? So this will become 0 and this will become like 75, right? So it will be 25 by 100 means 50 will come, right? So by doing that calculation, here you will get it as 75, it will be 50, right? 75 plus 50, it is 450. So total it is 125 by 450 means you will get it as 5 by 18 meters. 5 by 18 meters. So it is what m1 x1 mama kg, it is what m1 m2 m3 means what gram. x1 x2 x3 is in what, right, meter. So gram meter and here gram, so gram will get cancelled, no. So the final unit is meter. Similarly, so how we found x coordinate of center of mass? Similarly, you can find y coordinate of center of mass. m1 y1 plus m2 y2 plus m3 y3. m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. That is equal to, see here, if you do this calculation, it is what, here you will get it as 50 root 3 by 450. So here 0 0 will get cancelled and 5 1 5 9. So root 3 by 9. Root 3 by 9 is equal to 1 by 3 root 3 meters. 1 by 3 root 3 meters. It is what y coordinate of center of mass. So the center of mass is shown in the figure. So where we have shown, this is, see, 5 by 18 comma 1 by 3 root 3. 5 by 18 comma 1 by 3 root 3, right. It is what center of mass as shown in the figure. Okay, right. But okay, that's it. He is asking to find find the center of mass of three particles which were placed at the vertices of an equilateral triangle. Okay, so here it is what coordinates of center of mass as 5 by 18, which is what 1 by 3 root 3. Okay, so here it is 5 by 18 comma 1 by 3 root. It is the center of mass, position of center of mass. Okay, right. So this is COM is shown in the figure, right. Okay, now so problem is completed. So whatever he is asking, that we found. Okay, but now the thing is, here a small question, is it the center of mass in this case exists at geometric center of the triangle OAB? So why it doesn't exist? Okay, now you see the next question. By going through the next question, you will come to know why it doesn't exist. Okay, right. See here, next question, example 7.2. The question is as simple as such: find the center of mass of a triangular lamina. Find the center of mass of a triangular lamina. So this is the lamina. So lamina means, you just imagine like a plate. For example, that is what just like a plate. So you know that is what exam pad, right? So you remove the clipper, and if you see the exam pad, it is like a wooden plate. It is like a wooden plate, right? So in a similar manner, you have to imagine a lamina. Okay, here they have given one lamina, that is what LMN. Okay, so this lamina, for this lamina you have to find center of mass. It is what a triangle in shape, no? So that it is a triangular lamina. Okay, right. See this. The lamina may be subdivided. That is what triangle element into narrow strips like this. Okay, each parallel to the base MN. Right, as shown in the figure, right. By symmetry, each strip has its center of mass at its midpoint. That's you know very well. Ungalku theriyumo, right? Because how to find the center of mass, you know, right? So based on that, based on the geometrical structure, you can find. So by symmetry, each strip is one strip and another strip and another strip and like that. Each strip has its center of mass at its midpoint. If you join the midpoint of all the strips, we get the median LP. This is what L and this is what P. Okay, we get the median LP, right? See here. we get the median LP, right? It is what? L, and it is what? P. See here. Similarly, we can also argue that it lies on the median MQ. This is what? So whatever the point you are taking, that point you cannot say that which exists on LP, because that point is also present on MQ. See here, right? So what he is saying is, the center of mass, if you join the midpoint of all the strips, we get the median LP. It's okay. The center of mass of the triangle as a whole, the center of mass of the triangle as a whole, therefore has to lie on the median LP, on the median LP, right? On the median LP, right? Similarly, we can argue that it lies on the median MQ. It lies on the median MQ and NR. MQ and NR. Okay, full stop. This means that the center of mass lies on the point of concurrence of the medians. This means that the center of mass lies on the point of concurrence of the medians, that is on the centroid G of the triangle. That is on the centroid G of the triangle. Okay, that is what he is saying. That is what he is saying. Okay. Here they have given one triangular lamina. This is what triangular lamina, asking to find the center of mass. First, this lamina we are going to subdivide it into narrow strips. Okay. So when we are going to subdivide it into narrow strips, and which is also parallel to the base of the lamina, and for all these narrow strips, any one narrow strip, its center of mass lies here, and for this here, and for this here, like that. If you join all these center points, it will give us a median LP. Similarly, we can argue that it lies on the median MQ and NR. Okay. This means the center of mass lies. This means, because this point is already also present on MQ and NR, we can argue that. Okay. This means the center of mass lies on the point of concurrence of the medians, that is on the centroid G of the triangle. Centroid G of the triangle. Okay, right. Now, next example problem, that is what example 7.3. Right, see here. Find the center of mass of a uniform L-shaped lamina, in the bracket a thin flat plate with dimensions as shown in the figure, right? So find the center of mass of a uniform L-shaped lamina, that is what, in the bracket a thin flat plate with dimensions as shown, right? So here the mass of the lamina is 3 kg. The mass of the lamina is 3 kg. Okay, right. And this is also what, uniformed L-shaped lamina. See this L-shaped only, no? That is, okay, right. See this. Choosing the x and y axis as shown in the figure, we have the coordinates of vertices of the L-shaped lamina as given in the figure. So what about the coordinates of vertices of the L-shaped lamina? Here they have given, right? Next, we can think of the L shape to consist of 3 squares like this. Each length 1 meter. Okay. Next, The mass of each square is 1 kg because it is a uniform L-shaped, uniform lamina. So the mass is distributed uniformly, so that you can assume mass of each square is 1 kg. Full stop. See this picture also, ma. The center of mass C1, C2 and C3 of the squares are by symmetry their geometric centers and have coordinates. This is what 1 by 2 comma 1 by 2, and next 3 by 2 comma 1 by 2 comma 1 by 2 comma 3 by 2. You know very well it is what 0 comma 0, and it is what 2 comma 0, it is what 0 comma 2 when it is 2 meters. When it is 2 meters, this is what 2 comma 1 no, it is what 1 comma 1 no, it is what 1 comma 2 no. So these C1, C2, C3 are the center of mass of individual plates like this. This is what, by combining all the things we are getting L-shaped lamina. L-shaped lamina. Okay, right. And we also can take, because of uniform distribution of mass, we can also take mass of each square like this is 1 kg. Okay, now we take the masses of the squares to be concentrated at these points, right? The center of mass of the whole L shape XY is the center of mass of these mass points. The center of mass of the whole L-shaped lamina X comma Y is the center of mass of these mass points, right? So for all this, where is the center means that is the center of mass of the L-shaped lamina, right? So now we are going to find, as usual, let's x is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. That is what 1 into 1 by 2, each one is 1 kg. Okay, 1 into 1 by 2 plus 1 into 3 by 2 plus 1 into 1 by 2 divided by 1 plus 1 plus 1. That is equal to 5 by 6 meters. That is what, it is 1 by 2 plus 3 by 2 plus 1 by 2 divided by 3. It is what, 3 no, right? So then automatically here it will be kg meter, here it is kg. So kg will get cancelled and meter is the remaining. So it is 5 by 6 meters. The x coordinate of center of mass for the whole lamina is 5 by 6 meters. Now you go for y coordinate, that is what m1 y1 plus m2 y2 plus m3 y3, right? So that is 1 into 1 by 2 plus 1 into 1 by 2 plus 1 into 3 by 2 divided by 1 plus 1 plus 1. So in the numerator the units are kg meter and the denominator the unit is kg. So kg will get cancelled, remaining is meter. So it will be 5 by 6 meter. 5 by 6 meter. If you observe carefully, the x coordinate and y coordinate is same. That is what 5 by 6 meters, and this is also 5 by 6 meters, right? Okay, generally meter okay, right? But numerically also equal, no? 5 by 6 and 5 by 6, right? So what can we say? The center of mass of the L-shaped lamina lies on the line OD, right? So the center of mass of the L-shaped lamina lies on the line OD, full stop. We could have guessed this without calculation. Without doing this calculation also, you can guess. Why? Because in our previous class, I concluded that in case of regular bodies, the center of mass present at its geometrical center, right? In case of irregular bodies, we are not sure about the position of center of mass correctly and exactly. But in case of regular bodies, we are sure. So that what I am saying is, even without doing these calculations, you can expect where is the center of mass for this L-shaped lamina after seeing this figure. Okay, right. So we can guess it, no problem. Can you tell why? See here. So he is giving some more information. Suppose the three squares that make up the L-shaped lamina of the above figure had different masses. Then what will happen? Had different masses. How will you then determine the center of mass of the lamina? So here in this picture, the mass of each lamina is 1 kg, 1 kg, 1 kg and the madri, right? But if there is a different mass, for example, this is one mass, suppose it is 1 kg, it is 2 kg, it is 3 kg, then how can you find? It is the question he is keeping in our mind. We will think of solution, right? That is, okay ma? So here in our class, in this class, we found the center of mass of 3 particle system when 3 particles were present on the vertices of an equilateral triangle. That is, we completed in example 7.1. In the example 7.2, this second example problem, we focused to find out the center of mass of a triangular lamina. This is what triangular lamina. So here I told you, but here our main interesting thing is, we are keeping the geometrical structure of the figure. That is the important here, right? There is no calculus, as simple as such. The properties of triangles and the geometry of the picture gives the solution here. What is centroid, right? What is the base, what is the vertex, right? What is the median? That and all is important here to identify the center of mass of a triangular lamina. It is a triangular lamina. Next, in example 7.3, he has given one L-shaped uniform lamina, right, with dimensions, and the mass of the whole lamina is 3 kg. But according to the statement, that is what uniform distribution of mass, you can take each square mass as a 1 kg. Afterwards, based on the coordinates, that is what x-axis and y-axis, we found the coordinates of center of mass, x coordinate and y coordinate center of mass, that is what 5 by 6, 5 by 6 according to the given values, right? So finally, we find out the center of mass, right? And without this calculation also, here you can find the center of mass. It's not a problem. But the question is, if they have different masses, how to find the center of mass? Okay. So that question will get, for that question we will get solution with our coming classes. Okay. Thank you. We will discuss in the next class. Continue.